Bridge engineers are in a constant fight with gravity. Every joint, angle, and dimension has to be perfect. Even a small miscalculation can cause a major disaster. Like this bridge failure in Minnesota, a fatal collapse on one of the state's busiest crossings.
Seeing it crumbled in the river was nothing like I'd ever seen before.
This rush hour disaster revealed a deadly design flaw.
I thought I was going to die, and you just waited for that wave of concrete to gobble you up and to take you away.
The tragedy left everyone asking, why did it fail so catastrophically? Minneapolis, the name means waterfall city, and it thrived thanks to America's most iconic river. Stacy Bengs is a local journalist.
Minneapolis was built around the Mississippi River. There's so much life and color in the city. It's a source of recreation, but more importantly, the city is built around the power of the Mississippi River.
All that power carved a gorge through the land, and as the city grew, so did the need to cross the river.
Minneapolis now has more than 20 bridges crossing the Mississippi. Without them, the city would grind to a halt.
The St. Anthony Falls Bridge is one of the busiest. It carries I-35 over the Mississippi, a crucial connection on an interstate running from Minnesota to the Mexican border. In 1964, construction started on the original 8-lane crossing, the I-35 Mississippi River Bridge. Engineer Dr. Matt Rouse is a bridge research specialist.
So the I-35 bridge in Minneapolis was designed and built in the 1960s. The style of bridge, this deck truss, the basic structure of the bridge has two of these large trusses which are parallel to each other, and they support the deck that the traffic moves on.
Each 325-meter truss was a lattice of horizontal, vertical, and diagonal steel members, all connected by multiple gusset plates.
This gusset plate is a steel plate that connects several of these truss members that all meet at a certain point. So for example, there's a gusset plate right here, right, which is bolted or riveted to all of the individual truss members. And that gusset plate holds those members together. And if the stress gets too high on that gusset plate, it can rip or tear.
Gusset plates are found in all kinds of steel structures, not just bridges, but stadiums, television masts, even the Eiffel Tower. They're like the glue that hold these huge objects together.
The 35W bridge opened in 1967, and for 4 decades carried more than 100,000 vehicles a day over the Mississippi.
The 35W bridge connects people, it connects life. It's part of the heartbeat of Minneapolis.
On August 1st, 2007, construction workers and cement tankers were on site, waiting to resurface the bridge. 4 of the 8 lanes were closed. Andy Gannon was driving across town.
That day I was heading to a wake of a coworker of mine whose father had passed away. And when I got on the bridge, got on a little bit, and the first thing I heard was a loud boom, and the bridge moved lateral. And I thought, well, that was weird. I thought maybe that was a barge that hit one of the beams in the water.
But this was no barge. At 6:05 p.m., motion sensors triggered a surveillance camera. The 40-year-old bridge failed without warning.
So you watch the bridge buckle up and lifting cars up, and some of the cars falling down over the sides. It lifted my car up. I remember being up above everybody, heard a loud boom. That was the bridge coming back down.
Almost 140 meters of the central span dropped into the river.
We all free-falled and just rode it down, and my life flashed before me, and definitely thought that was going to be it.
More than 100 cars went down with the bridge.
For about 3 to 5 seconds, it was the most eerie quiet, the most eerie silent. And at that moment, I actually thought I had died.
Deputy Fire Chief Don Leadham was on duty when the call came in.
35W bridge is right off to our left, and normally it looks like that. But on that particular day, the cement kind of had a horizon line, and you couldn't see the part that actually went over the river because it didn't exist anymore. It was like, nah, that can't really be it.
As Don and the fire crew arrived, the scale of the disaster hit home.
It became evident that they were going to be going into a very fluid situation. The bridge had just collapsed. It by no means seemed like it was stable at the time. We still had cars up on top that were letting loose and sliding down and falling off the ledge.
Journalist Stacey Bengs also witnessed the devastation firsthand.
I only lived about 3 or 4 blocks away, and I heard and felt something. Somebody even asked, "Did you guys feel that?" And I looked out my balcony and I saw the fracture sticking up in the smoke. I was in complete shock, and my gut instinct was just to get my cameras and go there.
Nearly 200 people had been on the bridge when it fell. It was a race against time to rescue them.
It was shocking and it was unbelievable to see.
I was calling my wife to say goodbye. I thought for sure I was going to die. If I could get her on the phone for even 2 seconds to say I love you, that would be good enough for me.
Not everyone was as lucky as Andy. 145 people were injured. Tragically, 13 died. The nation was left asking, just what had gone wrong?
It's haunting to this day when I think about what people on the bridge went through when that went down. I think we were all just kind of in a collective shock.
In the wake of the disaster, an investigation was launched to discover why the bridge had collapsed and why so suddenly.
One question was whether the combination of construction equipment and heavy rush hour traffic was to blame. These added more than 600 tons of weight to the centre span. But that in itself shouldn't have triggered the collapse.
Detailed inspection of the CCTV delivered a crucial clue.
By analyzing the footage, investigators were able to pinpoint exactly where the fail started. And they discovered it was a specific set of gusset plates, the very things that held the bridge together.
The first part of the bridge to fail was identified on the south side of the central span, with gusset plates known as the U10 node. The steel plates were found to have buckled and fractured completely. As the bridge dropped, the exact same plates on the north side cracked, and the center span was doomed. Bridge specialist Dr. Matt Rouse explains.
This type of bridge is very non-redundant. So if there is a localized failure which causes one of the trusses to fail, the whole bridge comes down.
So why did these critical plates fail? Investigators uncovered a tiny but crucial design flaw in the original plans.
This gusset plate that we're talking about that failed is about 10 feet wide and 6 feet high. It's a huge piece of steel. And this one in particular that failed was about a ½ inch thick. And according to the code and the design standards, it should have probably been closer to 1 inch in thickness. It did not meet the standards of the day, and it certainly didn't meet the standards of today.
That small miscalculation ultimately proved catastrophic. And yet the bridge had stood firm for 40 years with the flaw hiding in plain sight.
City historian Laurie Williamson explains.
This is an infamous gusset plate from the 35W bridge over the Mississippi River that collapsed in 2007. I think it was a combination of design flaw from the get-go, of it not being thick enough, but I also think that there was a lot of wear and tear on it that weakened it to a point where it ultimately failed.
Decades of pounding by traffic and the weight of construction equipment proved to be a lethal cocktail.
It was a perfect storm of all the right combinations. It couldn't take it and the whole bridge came down.
The city was in mourning, but the I-35 was a vital link and had to be replaced. On September 18, 2008, just over a year after the tragedy, the new 10-lane St. Anthony Falls Bridge opened to traffic. This time, engineers weren't taking any chances.
Bridge engineering had come a long way in 40 years. Instead of a fracture-critical steel truss, which risked collapse if one plate failed, the new bridge uses multiple concrete girders, meaning it's a much more robust, safer crossing.
So for example, instead of two major structural elements of two parallel trusses, we might have several parallel beams, each which supports a smaller portion of the deck. And the idea there is that with more redundancy, the consequences of a local failure are much smaller.
Minneapolis was on the move once more. But lessons from the failure continued to reverberate through the engineering community.
This bridge collapsed. Departments of transportation all around the country suddenly scrambled to increase their inspection programs, especially bridges of similar design, to make sure that they didn't have a similar situation on their hands that had gone undetected.
It was a reminder of the risks in older infrastructure. In Minnesota, inspectors now assess fracture-critical bridges at least every 2 years.
What I've taken from this situation is really a broader look on life and my own life and what really truly matters, what really doesn't matter, because when you come close to dying, at that moment I remember going, I don't want to die because I'm not done.